Hi, this is Mr. Max with Sankofa Mathematics. So I have a question here. Um, it says you're supposed to solve the equation 81 raised to the power of 2 raised to the power of sine square x plus 81 raised to the power of cos square x is equal to 30. These are typically questions that you are going to see in the Olympiads type of mathematics, or even uh, other countries using similar questions in their examinations. Okay, so let's get down to it and let's look at this question. I also put an interval there for the solutions x. Once you find those angles, for them to be between 0 and 2 pi radians. In degrees, that's 0 degrees up to 360 degrees. I think worth mentioning is that 81 can be written as 3 raised to the power of 4. Those of you who rely so much on a calculator, 81 can be raised as 3 raised to the power of 4. That is writing 81 in prime factor form. So I'm going to start off by writing that 81 as 3 raised to the power of 4. And this is sine square x plus 3 raised to the power of 4. And this is cos square x. All that is equal to 30. Okay. Another thing perhaps worth bringing in, and I hope that you know the basic trig identity, Pythagorean square identity. It's that sine square of an angle plus cos square of an angle is equal to 1. And if I was to make sine square of an angle the subject of a formula, it's going to be replaced by 1 minus cos square x. Okay? Or if I was to decide to make cos square x the subject of the formula, then it's 1 minus sine square x. So it's totally up to you which one do you want to replace. If you have everywhere now where you have the cos of x, I will replace it with 1 minus sine square x, or I could have ordinarily chosen sine square x and I will replace it with 1 minus cos x, cos square x, in order for me to have them raised to the same type of trig. Alright, and that brings me to 3. So here I can go ahead and I can multiply out the brackets. Alright, but here I'll be a bit careful because the cos square x is now being replaced by 1 minus sine square x, and that is equal to 30. So I have a few more things to do over here. I will say that 3 raised to the power of 4 sine square x plus, so obviously now what we're going to do is I'm going to multiply this 4 over here in the brackets, and I'm going to have 3 raised to the power of 4 minus 4 sine square x, alright, is equal to 30. Alright, another concept with noting is when you work with indices or exponents and you have a raised to the m minus n, it actually can be written as a raised to the power of m divided by a raised to the power of n. Okay, because if you have that, you're going to subtract the indices. So what that means is that I'm going to rewrite the second one. So this one is still going to be 3 raised to the power 4 sine square x plus, but this is now going to be 3 raised to the power 4, okay, upon 3 raised to the power of 4 sine square x. Because once you are dividing, you are subtracting the indices. And we're going to say let that equal to 30. Okay. All right. So another thing now maybe with noting, and I'll bring that in, is that I see that 3 raised to the power of 4 sine square x in my equation, I can let that equal to some letter, perhaps the letter k. So everywhere where I have that, I'm going to replace that with k. So that now means that I have k plus 3 raised to the power of 4 over k is equal to 30. Again, remember that this somehow becomes a quadratic. So this is going to be k plus 81 over k is equal to 30. So what we're going to do is we're going to clear that denominator by multiplying throughout by k. So if I do it on the left hand side of the equation, I should also do it on the right hand side of the equation. And ultimately this will give me a quadratic equation. This is supposed to be 81. This is supposed to be 80, but the 30 over here is going to be 30k. So I'm going to bring that 30k over. It's going to be a minus 30k plus 81, and all quadratic equations are equal to 0. Right, so what that means, if you were to factorize, so you look for two numbers, if you multiply them, give you 81. And if you were to add the two numbers, you should get negative 30. So again, you can use the quadratic equation formula. Well, the two numbers must be identical with negative and a negative. And by trial and error, you should actually arrive at this one very easy. The numbers is negative 3 and negative 27. Okay, here's the thing that perhaps I should just indicate. The coefficient of our leading term is 1, and if that is the case, I can just go ahead and I can immediately open the brackets, and there are two negative numbers, and one will be negative 3 and the other one will be negative 27. So whenever you multiply two numbers and you get an answer of 0, it implies that one or the other is equal to 0. Solving for k will give me that k is equal to 3 or k is equal to 27. However, maybe before I can see something here that is quite useful. This 27, I'll write it as 3 raised to the power of 3. But remember, I said let that k equals to 3 raised to the power of 4 sine square x from our working before. So I'm going to replace my k now by that very 3 raised to the power of 4 sine square x, and it's going to equal to 3 raised to the power 1, or 3 raised to the power 4 sine square x is equal to 3 cubed. If the bases are the same with exponential equations, then we equate the indices. So 4 sine square x, so basically I'm dropping the bases, and I'll have left with the following. All right, so I am then equating the indices. All right, I think you realize we're getting closer to something that is more workable, right? So in any case, you're going to have here sine square x is equal to 1/4 dividing throughout by 4. So you're going to divide here by 4 and you're going to divide there by 4. And we're going to do the same on the other side. I'm going to have sine square x is going to be 3 over 4. Again, this is basic. We divide both sides of the equation by 4. So we're going to have, we have got sine square x is equal to 1/4. Now, sine square x, this is something that you should remember. Sine square x is the same as sine x times sine x, which is also something that we can look at this way, sine x all squared. So once we want to get rid of that square, we're going to take the square root. So we're going to take the square root of both sides. So we're going to look at the square root of here over the square root of that, the same the square root of here on square root of that. So in any case, we are left with sine x alone, and is equal to, well, the square root is going to be a positive and a negative number. That's the thing you must realize with the square root. The square root of a quarter is 1/2, or this other answer will be sine x is equal to positive or negative the square root of 3 upon 2, because the square root of 4 is 2. Right. So we have got, basically, if you are looking at what we have, we can decide to work with the first, and then we come to the second one. And our domain for our answers is given to us as x is between 0 and 2 pi radians, and we are supposed to solve the angles accordingly. Right, so if we are looking at something that I think you should be familiar with, and it's not really, it helps, I guess, in mathematics to know that, and it's what we call the cast diagram, the cast diagram. So in this quadrant, all the angles are positive, all the ratios are positive, and in here the sine ratio is positive. So in the first instance, where I have sine of 1/2, I will obviously want to find what is that key angle. Okay, that key angle will be the one that is going to guide me. So let me find the key angle by saying, okay, the inverse sine of that, and I hope you can go ahead and use a calculator, all right, or you should be able to recognize that the answer is supposed to be 30 degrees of pi upon 6. So shift sine, again, I was pointing in this here, the display, make sure your calculator is set to radian mode, because we are supposed to give the angles in radians, as our domain is given to us in radians. So that's 1/2 over here, and that's going to give me my reference angle, which is pi upon 6, which basically will also be one of the solutions that I'm going to consider. So I'm going to have pi over 6 radians. Okay, so now let's work on that first concept, because I'm going to write here just to have the space. So sine x is equal to 1/2 when it's positive, and we have realized that our angle that we said our key angle theta. So we just have the space here ready, so you can follow our key angle here, that our acute basic angle was pi upon 6. So our solutions would be x would be pi upon 6, that is in the first quadrant, and in the second quadrant, remember, if this was to be on this side over here, this angle will be this whole obtuse angle here, so it must be pi minus our angle. So in our case here, one of the solutions would be pi minus pi over 6. Okay, so that gives you 6 pi minus pi over 6. So the answer is 5 pi over 6. So this is also one solution, and this is one solution when sine is positive. Of course, remember, we also had that sine is negative, so you had sine equals to negative 1/2, and from our cast diagram we know that sine will be negative in the third quadrant over here, which means the angle we're going to have to look at will be all the way this reflex angle, which will be pi plus our angle. So one of our solutions here would be pi plus our reference angle, which is pi upon 6. So this gives you 7 pi over 6 as one solution, and another one with noting, obviously, in the fourth quadrant our angle is going to be obviously all the way. So it is then that 2 pi, the 360 minus our angle. So I'm just going to write also that solution over here. So I'm going to say, well, x would be 2 pi minus our reference angle, okay, and that should give me 12 pi minus pi over 6, which is 11 over 6 pi. Okay, so this is our solution when you have that negative half. So we are going to do the same for the sine x, which is the cube root or the square root of 3 over 2. So we have got sine x is equal to this one here, but this one is strictly, as you can see, you don't have two solutions as well. It's going to be both positive and negative. All right, so we're going to use the same type of scenario where first I'm going to look at what is the basic acute angle that I'm going to receive. The basic acute angle, which I'll maybe suggest maybe you can take your calculator if it is that you have a problem. So our basic acute angle in this particular case would be the inverse sine of root 3 upon 2. Actually, let me just make sure. Root 3, go out there and I put it on a fraction upon 2, and that gives me 30 degrees, which is pi over 3. Of course, that is our acute basic angle. So again, if we were to bring in our cast diagram, obviously we say that our acute basic angle here, one of them, obviously this is a solution, and if I go when it's positive, so I'm just going to work when it's positive for now. So the sine x equals to positive root 3 over 2. What is one solution? So one solution for x is nothing but pi over 3, or another solution is going to be this whole angle over here, which is going to be pi minus our theta, and in this case it's going to be pi minus pi over 3, which obviously if you were to calculate it, you're going to get 3 pi minus pi upon 3, and it's 2 pi over 3. So that's another solution. Okay, so we are now going to look at when the ratio is negative, that is sine x is equal to negative root 3 upon 2, right? So we're going to be in the third quadrant. So now that means we are working with the angle all the way from here all the way up to there, which is pi plus our theta. So our solution, one solution would be pi plus our reference angle, and our reference angle was pi upon 3. That is going to be 3 pi plus pi over 3. So our answer is 4 pi over 3. That's one solution. Then the other solution that we are going to have is obviously going to be the reference angle. But now I'm going all the way. The angle that I'm looking for is all the way around. So to find that angle there, it's within my given domain. I'll say 2 pi radians minus theta. Okay, so again, I'm just going to write that one here. So our x is going to be 2 pi minus our theta, or our basic angle, which is 6 pi minus pi over 3, and we have 5 pi over 3 as our solutions, right? So our solutions for x is all the solutions, the specific solutions I was looking for, and I wasn't giving the general solutions. All right, so perhaps I will start taking the ones that are closer to me. I have obviously 4 pi over 3. I have 5 pi over 3 as a solution, and then also have 2 pi over 3, and then I have pi upon 3, okay, and also the other solutions, and I'm just going to write that one under here or underneath here, perhaps with a different color. All right, the other solutions from our given problem right there in the beginning, when the fraction was a half. I had the values of pi as pi upon 6, 5 pi over 6. So one of the solutions was pi over 6. Another one was 5 pi over 6. Okay, let's just go back and refer back to it. 5 pi over 6 and 7 pi over 6 plus 11 pi over 6. So 7 pi over 6 and then 11 pi over 6. So these are all the solutions to this particular question. Okay, so let's just take one solution and perhaps we can see. So I'm going to take 81 just to test, and then I'm going to say, okay, 81, and I'm going to raise that to the power of, remember sine square x, I said that is going to be sine. So what the angle I'm going to use, again, pi over 6. So maybe I'll use pi over 6. So I wanted to find my pi radians, pi over 6. Okay, let's just close that. Well, go back there and close the bracket. So squaring that, and then coming down here, plus 81 raised to the power of, so we have got, I'll put it in bracket, cos, of course, our angle that I'm using is pi over 6. I'm just using one for you to see if we arrive at the same solution. All right, and we're going to come down here and let's see. No, remember I said it must be squared, so let's see if I hit equal to whether we get 30. You see that we get 30, so definitely it's a solution, and you can check all other solutions within the given domain. Thank you for watching. Good luck with your studies.